All right. Hi, everyone. In the previous videos, we have touched upon what we are trying to do. What the aim is that we want to introduce a function into OpenCV that basically takes a bounding box, it takes a frame number, and it takes a callback. What it's going to do is it's going to go and look at the particular frame number, not just trim, but figure out the ROI from that particular image at that frame number for the given bounding box, apply that callback onto that bounding box, and then save that image into the output capture. It's going to do it for a video. Imagine that you are walking in a video and you would want to blur yourself. That's the eventual goal. And for that, what we have done so far is we have made some changes. In the previous videos, we already did this, that we had added the CV wrap virtual bool function. Let me do wrap of this. So when you see what we are trying to do, we are trying to add a new function onto the video capture class, which essentially takes a bounding box, frame number, track callback. That's what it does, right? So we also have these cap ffmpeg.cpp file, where basically for any ffmpeg capture, it will end up calling that track method that exists over there, which is eventually defined here. Yeah. So you can see that this is the main logic of the function we have. And for each type of a video, for whatever, like it could be ffmpeg or something else as well, we do have our own implementation in OpenCV. So right now I'm only doing it for FFmpeg, but there are other types as well that we would want to implement this function for. So that's a problem for another video. But for now, what I'm going to do is I'm going to go to this function. I'm going to look at this function right now. The thing is, so far we were able to figure out how to retrieve a frame for that particular frame number. Now, how do you retrieve that particular bounding box or ROI, for example, from that input image, right? It's very simple to do um, in OpenCV, that you have to create a rect object which essentially says, okay, give me x0, y0, and give me width and height, right? This is all it says. So for our case, x0 and y0 are going to be bbox 0 and bbox 1, and width is going to be clearly what? bbox 3 minus bbox 0, not 3 but actually 2, and height is going to be this. And it's very simple, like I tried explaining here, that the bounding box vector is going to be of this format: x0, y0, x1, y1, top left, bottom right. In this case, it's very obvious what's going to be the width. Width is going to be x1 minus x0, which is going to be bounding box second index minus bounding box zeroth index, and same for y1 and y0. Uh, Hopefully this makes sense. So far, we have calculated a rectangle, right? However, the coordinates look like. Now, to grab that ROI, all you have to do is you have to say ROI equal to mat object and this pass the rectangle over here, right? So within that that particular constructor, there is an overload where you are allowed to pass a rect object, right? So yeah, there you go, right? So whenever you want to pass a rectangle object, it's essentially going to give you that particular region of interest, right? So that will work for our case. You can look at the overloads if you are ever confused at, okay, what all exists. So in this case, we have already figured that out. Now we are safe to call ROI, which should also give you the output mat. Now, the thing is, even though if it works, the main point is for us to figure out where to store it, right? So in this case, I'm going to use an output array where it's going to say that, okay, this is where you should store the output. Otherwise, what's the point, right? So in this case, how do you do that, right? Because you have figured out the output. Now, this output is in that particular bounding box ROI, right? How do you really get the original frame where your output is over it, kind of merged on the top of the original frame, right? So in this case, what we'll have to do is we'll have to do mat object. You know what, like, of course, very firstly, output array is not equal to mat, right? So this is one thing we have to understand. So let's go back here. Let's look at whatever we have. So we do have underscore output array, and what am I looking for is a function that takes. Yeah, there you go, right? So what does it give you? it's a create object that takes rows, calls, type, right? Everything else looks like, by the way, is optional. So this means I already have rows, calls, and type with me. I can pass dims over here. That's better in this case. And what can I do? Do you have any mat object here? There you go, right? So I'm kind of looking forward to any. There you go. There's a get mat ref. But is there anything that kind of allows me? Yeah. Oh, okay. Cool. So there's a get mat as well. That will just give me the mat object from this particular output array. So in this case, all I need to do is, I think we can go back here, right? And what we'll do is we'll do cv mat result. Um, Actually, you know what? We'll have to do result dot create. Doesn't return anything, by the way. The return type was void. What are we looking forward for? We're looking forward to the original mat object dot size. Hope I can do size mat object dot type, right? So you basically pass the dimensions and the size, right? And the type as well. Yeah, this is the format, right? By the way, like you could have also done this, but any of these are fine for me right now. Not a matter of concern. Now, what do you do that, right? What do you do after this? How do you really merge the output and the original image and all of those things? It's comparatively like, let's not forget, by the way, let's get a mat object here, result mat, right? So we already have this, right? The next step, of course, is to merge both of them. We have output, which is what we're going to merge on the top of mat object, right? So first, let's get result mat. We'll do mat object dot copy to result mat. Okay. So what this means is result mat contains the original mat object, right? And then what we'll do is output dot copy to result mat ROI, right? So in this case, what it will do is it will, for that particular ROI within the result mat, it's going to have the output, whatever we had there, and then it should work, in my opinion. Um, so we can go ahead and merge, but before that, just notice that, okay, we have added a new function. I mean, added a new parameter to this definition, but we haven't really added to the declarations. So let's do that. Let's let's do the formality. Um, yeah, okay. You know what? I think it's going to be easier for me if I kind of just watch all the. Yeah, I think this is done. Sounds good. So let's go to cap ffmpeg.cpp now. We have track, output array, result. This is also good. We should go to cap ffmpeg impl.hpp. I think we already got it covered, right? And this is where and cap interface. Yeah, there you go. Yeah, we possibly don't need the name here, so we should be good. Okay, so we are done. I hope, yeah, this is not required. Videoio.hpp. Yeah, I believe this is, oh, this is one of the most important points, right? This is where it understands how to pass it on to Python. Sounds good. Okay, so we should be good. So let's go to build. I'm not sure why am I doing this, but okay. Is it failing or these are unused parameters? Uh, this is in cap interface.hpp. Ideally, we could have just avoided naming those files. So that's okay. It's only in cap interface.hpp. Everything else seems to be running fine for us. So what I could possibly do is go back. Where am I? Yeah. We could ideally go back, but let's not go there. Let's try to first see, not this one, Python path equal to build lib python 3. I'll open a shell. No, not this one. We'll have to create a capture object. Okay, so I did ask Claude to create a script for me that eventually tests whatever we are trying to build so that I'm sure what it's trying to do. Overall, all it's trying to do is it looks at the Python, I mean, this video file. All it does is it has bounding box and frame number. It's creating a video capture object, getting that particular frame so that you can eventually compare what you have. It will draw a bounding box on the top of it for you to understand which part of it is supposed to be changed. You call the track method with bounding box, frame number, and the callback. All the callback does is it draws a line, a diagonal line in that rectangle, and that's it, right? And then eventually we'll write this object. So let's do this. Sorry, track visualize.py. Okay, it does fail. It says assertion failed. Channels equal to. Okay, oh, I think we did something wrong here in copy too. So that means we are not really copying correctly because, okay, you have result mat. Okay, you did result.create mat object.size mat object.type. Um, I don't know what's happening here. I hope I'm calling the right one. CV mat type, right? Should work fine. So we do have result.get mat object.copy too. So within the result mat, after this we have mat object as it is, and mat object was the original one. This was also fine. We did get the ROI. Okay, my bad. The problem over here was very simple. We are trying to pass the mat object into result mat. Instead of this, we had to pass the bounding boxes. That was the mistake because when you go to any mat object, I think we discussed, right? It takes a rectangular object and not a mat when you want to do this. Let's try to build it again. Hopefully this time it builds fine. What happened here? These are typing stubs, right? I hope it's something that doesn't really block our work. We'll wait for this to finish. Ideally, this should have been faster, but okay. I think I'll have to wait, everyone. Um, Once this is done, we'll get back to it. Okay. Yeah, this is a lot. While this happens, we could possibly go to track visualize.py. We could see what we are trying to do. Over here, by the way, we are also trying to write the video into a particular file, right? So what we do is we have output path is track output.mp4 file. You create from the original, like whatever, this is a video writer, but this is also video capture. So you have video capture and video writer. You will write the output per frame to this video writer, and this is something that we'll have to change because right now this is per frame. We are explicitly checking if that particular frame number is this one, then only you do cap.track. Kind of makes sense given you have a frame number, so you could do that. Doesn't really stop you from doing it, but ideally it should not be this much effort, right? So we'll have to think about it. But for now, what it does is for every other frame, it just reads and gets that frame as it is and writes it. For our get cam.track, it takes the frame and then writes it as well. But this time, this frame is the output array, right? It's not really something that we received originally. So uh, we are at 95%, so we should be good anytime soon. Um, but anyways, like this will write the output and we will get to see just notice that there are a couple of things we are writing. One is visualize.png, that's going to contain a horizontal stack of original annotated, which means the original bounding boxed annotated image and merged image. I mean, merged as in like whatever we have drawn using the callback. And the callback is very simple. We are drawing a diagonal line. As you can see, this is the diagonal line we are drawing. Okay. This is done. Let's call this awesome. Okay, it was able to write the file. Now let's go and look at this particular file. That should help. There you go. Let me zoom in for you all, and then show it again. Okay, you know what? Yeah, there you go, right? So as you can see, what's happening here is you have that particular 5, which was on the left side. I've drawn a rectangular bounding box on the top of it. And on the right one is that particular output from the track method we have implemented in OpenCV. And if I had to go to track output.mp4 file, you will see that there you go, right? So at this particular frame, you would see that this was drawn into that video, which is the output video, right? And in the original video, of course, that was not there. So it kind of helps what we're trying to do, right? I hope this gave you a brief idea on what we can do with OpenCV. There's so much to do. Um, but yeah, in the next video, we'll try to cover on how do we avoid having a for loop within our Python function, and how do we make use of DNN module, which is going to help us track a face instead of these bounding boxes, instead of these rectangles. Now we are going to get deeper into how to use DNN module, how to even use different facial detection mechanisms that OpenCV has. Used to use Casmi. I don't even remember the name, face mark algorithms that they used to have, and we will explore and we'll see which one suits the best, and we'll do that. All right, guys, thank you so much for being here. It was a longer video than I expected, but hope it kind of taught you something today. If you like the content, please do like and subscribe. Bye bye.